This is lesson 5-8 on solving equations by factoring. First thing we need to understand is something that's called the zero product property. This means if we multiply two numbers or two terms together and it equals 0, then it means that either one of the terms, A, has to be 0, or B has to be 0, or both of our variables would be equal to 0. The definition of the zero product property is any number times 0 is going to be 0. So we can apply that to a problem like this. What we've seen in the past is problems that just are x plus 3 times x minus 5. But now it says it's equal to 0. Well, in this problem, we actually have two terms. One term is x plus 3, and one term is x minus 5. Well, the only way this problem could be equal to 0 is if one set of these parentheses was equal to 0, or possibly both. So we want to figure out what our values of x could be. So we're going to take each of our terms, x plus 3 and x minus 5, and set them equal to 0, and solve for x. This is similar to when we were trying to find the excluded value in our functions, and we were setting our denominators equal to 0. It's very similar. So when we solve each equation, we get x equals -3 or x equals 5. If we plug -3 into the original equation, we'll have -3 plus 3, which is 0, or we'd have 5 minus 5, which was 0. So both solutions would be true. Okay, let's try another example. In this example, we have a factored problem on the left-hand side of the equal sign, and it's equal to 0. Again, we have two terms, 2a plus 4 and a plus 7. Terms are going to be separated by parentheses. So we're going to write two equations here. We're going to set them both equal to 0 to determine what a could be. So 2a plus 4 equals 0, a plus 7 equals 0. Go ahead and take a second to try to solve each of these equations. Okay, when you solve the equations, you should have a equals -2 or a equals -7. These would be the two values that would make this equation equal to 0. Okay, example 3, one more, where this is already a factored form. In a second, we're going to get into a couple harder ones. So this one I'm going to go through a little bit quicker. We're going to take each set of parentheses and set that equal to 0. 3t plus 5 equals 0, and t minus 3 equals 0. Go ahead and try to solve for the values of t. When you solve, you end up with t is equal to -5/3, or t is equal to 3. So those are our two solutions that would make this problem equal to 0. See if for this problem, if you can determine what the two answers are. If you need to write it out, you can go ahead. If not, see if mentally you can figure out what our values of y could be. We should have two answers because we have two sets of parentheses. We know right here, if we plug in a 3, this set of parentheses would be equal to 0. So I can for sure say that number 3 or number 4 would be a solution. Or possibly number 1. And when we do 2y plus 6, we end up with -3. Okay, the next thing that we have is problems that are going to look a little bit more difficult, but they're not. We're just going to have some factoring that needs to take place before we move on. So we have 4 steps for solving a quadratic equation. Well, first of all, a quadratic equation, that sounds like a pretty complicated term. It just means anytime we have a trinomial where we have an x squared term as our highest. So our first step is to set the equation equal to 0. Then we're going to factor the equation. And by factor, we can possibly pull out a GCF. We can factor using dots. We can factor using math or mathful. Then we're going to set each part equal to 0 and solve. And by each part, I mean each term, or possibly each set of parentheses. And then you're going to check your answers. You can do this mentally in the beginning. Okay, so let's take a look at this example. So this time we're not seeing the individual parentheses because this problem isn't factored. So that's going to be our job here. So x squared minus 11x, if we go through our methods of factoring, we see that there's a GCF. So I'm going to pull out that GCF of x. And when I pull out the x, I'm left with x minus 11. Even though this x is not in parentheses, it is still a factor or a term of this problem. So now to find my excluded values, I still have two equations that I'm going to write. And my equations would be x equals 0, or whatever was in parentheses, x minus 11 equals 0. Well, the one on the left is already solved, and the one on the right, x minus 11 equals 0, I can solve pretty simply. So my two solutions are 0 or 11. Okay, and problem number 5, this one's a little bit more difficult because it is not already equal to 0, so we need to make sure it is equal to 0. And also, since we're going to be factoring, we need to make sure that everything's in descending order. So we're actually going to add an a squared to both sides so that we can put it in descending order. By adding the a squared to both sides, putting it in descending order, it is now equal to 0. And now we can go ahead and factor it. This is a problem you would factor using math. Why don't you go ahead and take a second to make sure that you can remember how to factor using math. So hopefully you were looking for two numbers that multiply to 144 and add to negative 24. Well, that would be a minus 12 and a minus 12. You could also write that as a minus 12 raised to the second power. But what you need to know about that second power is really we have a minus 12 and a minus 12 twice. But our solution is just going to be a 12. Okay, number 6. This one is also not equal to 0, so I want you to see if you can take a second to try to put it equal to 0 and in descending order. Go ahead and pause if you need to. Okay, you're going to subtract 20m from both sides, and when you do that, it's now in descending order. 4m squared minus 20m plus 25 equals 0. This time, to factor, you need to make sure that you use mathful. Why don't you go ahead and pause here and factor this problem using mathful. Okay, so if you factored using mathful, you should end up with 2m minus 5 and the whole thing squared. Or you could also have 2m minus 5 and 2m minus 5. This is actually an example of a perfect square trinomial. So we're going to take 2m minus 5 and set that equal to 0 and solve for m. And when you do that, you should end up with m equals 5 over 2, or 2.5. Number 7, again we need to put this in descending order. And then after we put it in descending order, we need to factor out the GCF. When you factor out the GCF, you're left with x squared plus 2x minus 15. That x that is outside is still an important part of this problem and is still going to be included in your zeros. So we're going to take the parentheses, and I factored using math, and I went through this one kind of quickly because it's a pretty simple one. But what I want you to recognize right here is that we now have 3 terms. So we are going to set 3 different equations equal to 0 because there are 3 possible numbers that x could be. X could be equal to 0, that comes from my GCF. X plus 5 could be equal to 0, or x minus 3 could be equal to 0. If you solve each one of those equations, you end up with the possibilities of 0, negative 5, or 3 as possible answers. Okay, let's try another problem here. This one, I want you to take a second and pause, see if you can solve on your own, and then I'm going to click on the answer. And the answer to this problem is going to be -5 and 8.